Hello Internet, I'm your host Zaphod, and this is the Zap Labs. Today, we're going to be building some logic gates out of Redstone. Logic gates allow us to take more than one input and produce a single output based on the conditions of those inputs. So I'm going to use these redstone lamps with levers on them as our inputs, and the redstone lamps conveniently show us the state of the input by glowing. And the first circuit I want to build is what's called a pass-through circuit. This simply passes through the input signal to the output. So when the input is on, the output is on, and when the input is off, the output is off. Very trivial circuit. Next, let's look at a NOT gate. A NOT gate makes use of the redstone torch, which inverts the powered state of the block it's attached to. And we string this over to our output, and now the output is the opposite of what our input is. When the input is off, this allows the redstone torch to be powered, so our output is on. When the input is on, this turns off the redstone torch, so our output is off. And you'll notice the short delay in response of the output to the input, and that's because the redstone torch adds a 1-tick delay to your circuit. Next, let's look at an OR gate. An OR gate will combine two or more signals, and it will be on if any of the input signals is on. So if we string redstone back there, this will serve as the output, and as one of the inputs comes on, the output comes on. It doesn't matter which input is on. If either of the inputs is on, the output is on. And if both of the inputs are on, the output is on. Now if we combine the OR gate with the NOT gate, we get what is referred to as the NOR gate. So I will set up the same two inputs, and I will connect them back to this block in the same way, building our OR gate, but then put a redstone torch on top of this to give ourselves the final output. And this will behave at the exact opposite of the OR gate. So it will only be on when both inputs are off. If any input is on, the NOR gate will be off. And the next thing I would like to build is an AND gate. An AND gate, we are going to be using De Morgan's theorem, which you can look up on Wikipedia if you're interested. De Morgan's theorem states that if we invert the output and we invert all of the inputs, then we could substitute AND for OR and OR for AND. So with our inputs inverted by putting NOT gates on them, and our output inverted again with the NOT gate, this produces an AND circuit from what would normally be an OR circuit, that is this part in the middle. An AND gate will only respond with the signal if all of its inputs are on. So with both inputs off, the AND gate is off. As we turn one input on, there's no change, the output is still off. The output only turns on after both inputs are turned on. And if we remove the final NOT from the circuit, this will be equivalent to a NAND gate. A NAND gate is the NOT of an AND gate, And since the AND gate is already built with a NOT on its output, putting another NOT on there is a double negative. So we could build this without either of the NOTs, and that produces the same logical result. So this circuit is only off when both inputs are on. So as we turn one input on, the output remains on. It's only when both inputs are turned on that the output goes off. So to recap, these are basic logic gates that help reduce one or more input signals down to a single output signal based on the condition of those input signals. We have a pass-through circuit, we have a NOT gate, we have an OR gate, NOR, and finally a NAND gate. I hope that these help you in your Redstone builds, and as always, thanks for watching.